Hi, in this video we're going to talk about classification in machine learning and how that can be implemented with Python. So here I have a Jupyter notebook where I first import some necessary libraries. For example, pandas and numpy are used for data preprocessing, and sklearn is used to create the model and then evaluate it. And finally, matplotlib is used to make visualizations. So let's first talk about our data. So here we'll have a very small data set of only 89 samples, which are some meteorological observations from the Finnish Meteorological Institute. You can download this yourself by going to the FMI website, and you can choose like the time period and the observation station. But in our case, this is the time period is from November to December 2021, and I think it was only from the Helsinki region. So this is how the data looks. Yeah, so here the quantity of interest is this maximum temperature, but since it's a classification problem, we want this to take a binary value, so either 0 or 1 in our case. But let's first define what the data point and the label and the feature is. So a data point is an object with some specific properties, and the label is the quantity of interest, and the feature is the amount of information that we think we need in order to be able to predict the label. And in our case, as we said, the label is either a high maximum temperature or a low maximum temperature, and the features, like the ones we are going to consider here, are going to be the day and the minimum temperature. So here we only take the columns that we are interested in, and we drop everything else. And we also rename the columns to make access easier. And now we need to convert these maximum temperature values to either 1 if the maximum temperature is high, so we consider high temperatures every temperature above 5 degrees, and everything else consider low, or 0 here. So here we created this new label column, and now we need to drop the maximum temperature column because we don't really need it. So let's now visualize the correlation of the features and the maximum temperature. So as you can see, with the day, the maximum temperature doesn't really have any relation. This is like very noisy. But on the other hand, with minimum temperature, we see that as the minimum temperature increases, the maximum temperature tends to be high. So that means that since the day is not informative, we can simply ignore it or drop it in our case. And now we are only going to have this minimum temperature as a feature, and the label will be, well, the maximum temperature classification. So here I've taken these bullets from the machine learning book by Alex Jung, and it says that logistic regression is an ML method that classifies data points to two categories. And logistic regression uses the same hypothesis space as linear regression. So that means that in order to take a prediction of either 0 or 1, we need to compare this hypothesis value with a threshold. So if the hypothesis value is above 0, for example, then the prediction is 1, or otherwise the prediction is 0. And our goal is to minimize this average logistic loss, where the average is taken over all of our training examples. And we need to find these W hat parameters that minimize the loss. And this is very easy to implement in Python with the logistic regression class of sklearn. So here we train the model by using the fit method, and now to evaluate it, we are going to use these two functions, 0, 1 loss and log loss. So 0, 1 loss is a better function to evaluate the performance of the model because it has a higher value and a lower value. So a value of 0 means that we did not make any misclassification at all, and the value of 1 means that that every prediction was wrong. So yeah, but on the other hand, the average logistic loss doesn't really have a high value, so we don't really have a way to compare it with other models. And now we can see that our model is relatively okay, so it's pretty uncertain when the value is close to -4, the minimum temperature is close to -4, or below 3 or 4 degrees, and that makes sense because our data was kind of noisy in this range. But otherwise, the model is pretty good. So that's it about logistic regression.